Assalamualaikum and hello. In the previous videos, we've talked about for a given element, you might have different versions of an element, and that different version, we call it as different version of isotopes. And each isotope of an element can have a different atomic mass, and you can get the idea that if it's a given element, it's going to have the same proton numbers, but you could have a different number of neutrons. Now, one question that you might have been asking yourself, how have chemists been able to figure out what the various isotopes of an element are and their relative abundance? And you also may be asked about how and what percentage of an element that we can find in the universe is of isotope A versus isotope B, maybe. So the answer to your question is where the chemists use a technique known as mass spectrometry, or the machine that we can use is mass spectrometer. Sometimes you will hear the word mass spectroscopy. They are essentially referring to the same idea. And what this technique is that you put a little bit of a sample based on this diagram. You put a little bit of sample. Let's say we talk about magnesium. I put a bit of sample for magnesium here. And what will happen? You will heat it up. So right now, a bunch of magnesium is floating around here, and you will bombard it with a bunch of electrons from the electron beam source. So what electron bombardment does is it can knock off electrons from the atoms in your sample from magnesium atom by ionizing some of your atoms. So now they have charge. So once they have a charge, they can be accelerated through these electric plates. And now you have these ions, in this case magnesium, moving quite rapidly through this chamber until they enter into a magnetic field, which is very strong magnetic field here, that can bend the path and can deflect ions with charge. For a given charge, the force of deflection will be the same. But if you have a larger mass, you are going to be deflected less. And if you got a lower mass, you are going to be deflected more. So what you can see here, different isotope being deflected different pathway as they go through the magnetic field. And then you have a detector here. At different points, you will detect each of these isotopes at this detector. The more ions that hit a certain part of detector can have more type of isotope in nature. And then you can generate a chart that looks like this one or this one. Sometimes you will see it will label as atomic mass here for the x-axis and relative abundance for your y-axis. For your y-axis, sometimes you will also see that it will put as percentage abundance instead of relative abundance. They're referring to the same thing. And from here, you can see that magnesium 24 has the highest abundance compared to magnesium 25 because of the spectrum for this one is more taller than the others. So based on this graph, I can summarize for you that it all comes from this process of ionizing those atoms based on the previous slide and speeding them up, deflecting them through the magnetic field, and then the ions will have the higher mass to charge ratio, will be deflected less, and the ions that have a lower mass to charge ratio will deflect more. You can use that information to make a graph like this one, the mass spectrum. So a mass spectrometer can be used to determine the relative atomic mass of an element. The other way is it can also use to calculate the relative molecular mass of a compound, and you can also use the mass spectrum to determine the type of isotopes, the abundance, and its relative isotopic mass from the graph that I've shown you in the previous slide. And last but not least, you can also determine the structure of a compound for an unknown sample. So here you got the mass spectrum of magnesium, this is the graph that had been generated from the process of mass spectrometry. And this mass spectrum is a pattern that represents the distribution of ions by mass. Correctly, we use the term mass to charge ratio in a sample. So let's continue how I want to describe a bit from this spectrum about isotopes. So we've known that magnesium consists of 3 isotopes. The first one is magnesium 24, magnesium 25, and magnesium 26. You can see that there are different height for each line which are proportional to the abundance of each isotope at your y-axis. So isotopic abundance can be expressed in terms of relative abundances or percentage abundances. So it depends on the spectrum that you got in your question. Now, if you want to describe what mass spectrum from this graph, the first point you can see that magnesium 24 has the highest line. It means that magnesium 24 is the most abundant of 3 isotopes. However, magnesium 25 has the shortest line, so you can say it is opposite to magnesium 24. Magnesium 25 has the least abundance. So this is how you want to describe the mass spectrum of isotopes depending on which element you got from the questions. For the next video, we are going to relate how to calculate the relative atomic mass from the mass spectrum. So that's it for this video. I'll see you in the next one. Thanks!